Damn, new audio sounding kind of moist. What's good, everyone? Peter here, aka StudyMate, and today we are going to be jumping into the fourth video, Unit 3 of my Numerai Starter Pack series, where I try to give you everything you need to make your own model that you can eventually stake on in the Numerai tournament. Now, in today's video, we're going to be covering modeling. So we're going to look at how to actually take the data that we broke down in our last video, feed it into a machine learning model, and figure out, how to get the best model and choose from a variety of different models. So excited to have you here. Let's jump into it. So the first thing we're going to be talking about is model selection. Now, there are a ton of machine learning algorithms that we can choose from, depending on the problem that we're trying to tackle. But there are three questions that we need to ask ourselves to filter out all of the algorithms that might not be super applicable to what we're trying to do. The first one is about the task. So what are we trying to do? Is it classification, regression, clustering, dimensionality reduction? The second thing is, what type of data do we have? Is it labeled or unlabeled? So labeled just means that we have the value that we're going to want to be predicting. So for example, if we're trying to do stock analysis, your data is labeled if you have the stock price. And then lastly, how much data do we have? Certain algorithms do well with small amounts of data. For example, with deep learning, you're going to need a lot of data. So that's one question that might kind of point you in one direction or another. So what I have here is the scikit-learn algorithm cheat sheet. So for those who don't know, scikit-learn is one of the largest machine learning libraries for Python. And what they have here is kind of a roadmap of all the questions you should be asking yourselves. And eventually you'll end up at a specific algorithm that might do well for you. Now, we're not actually going to be using any of the algorithms from this cheat sheet. I just wanted to kind of include this to give you an idea of, how many algorithms are out there and some of the logic behind choosing the ones that we might want to test for the Numerai tournament. All right, so moving on, we're going to want to take a look at first this import cell here. So I've left in quite a bit of pre-typed code for this video. I'm not going to rehash stuff that we already covered in our previous video about the tournament data, but I will point out some differences in the inputs here. The first one is Spearman R, so some statistical functions as well as for correlation, as well as light GBM. And then lastly, of course, some functions from scikit-learn. So this is, again, one of the larger machine learning libraries in Python. So we're definitely going to want to be using stuff from there. So I'm just going to run this. Awesome. And then these three cells are exactly straight. I copy pasted them straight from the last video because we're still going to be wanting to download and import the data into a Dask data frame. And we still want some of these helper variables and columns to make our lives easier when working with the data. So I can go ahead and run that as well. So everything ran, no issues. Now, there is one thing that is a little bit of a problem that we are still going to need to tweak that is new from what we did in the second video. And that I'm going to point out here with this dot head, as we can see for our ID column. So this is obviously a hash. It's a string. It's not a numerical value. And this is going to trip us up a little bit as we try to do stuff like splitting a training and test set. So what I'm going to do in here is we're going to take out just the feature data into a separate variable and just work with that separate from this full df train data frame. So in here we have the X and the Y values. So, our feature data and all this additional stuff to help us, but we don't need all of that once we're trying to feed the data to a machine learning model. So that's why we're going to take it out. So the first one I'm going to do, we're just going to call this X train, and that's going to be, so this df train, but with first this reset underscore index function applied to it. Whoops, if only I could type. Awesome. And then the columns that I want from there are, again, these feature list that I created up above. So this is exactly the same to what we did in our last video. And then from here, I'm going to call this to_dask_array function. And that's just going to take all of this data and kind of self-explanatory a little bit, but we're just going to turn it into a Dask array. And that's going to make our lives easier again later on when we're trying to pipe this data into a machine learning model. So in here, we're just going to have to specify lengths, is equal to true. And that should be everything. Now we're going to want to also do this for our Y train. So I'm just going to go in here and make a couple tweaks. So I'm going to change the variable name to Y train. And then instead of my features here for the columns, I'm just going to put in target. So that's just the single target column in our df train data frame. I'm just saying I don't want the features. I'm just going to want the one target. So that's the only change we need to make there. I'm also going to make a third one called x_train_arrow. And this is going to be a variable that has the same data, but we're also using the arrow column that we made here. If we remember back to that one, and that is just taking the arrow column again, just to refresh your memory, is just this arrow column, but turned into an integer. As you can see with the leading zeros, it's not, it looks like an integer, but not really. It's actually a string. So we're going to do the exact same thing. But instead of features here, we're going to do features_arrow. And this again is just the features, same features variable but with this new arrow column created. And again, to_dask_array. Lengths is equal to true. And I'm missing the G again, but we're good. Awesome. So I'm going to go ahead and run this. And this is just going to, again, give me all of this data, but in this nice Dask array so that I'm able to more easily put it into my machine learning model when we want to train it and do some model selection, etc. So I'm going to do a quick cut here because this might take a little bit, but I'll see you in just a sec. Nice. So now that our data is imported, we can quickly talk about cross-validation. Now, the reason we want to do that is because in our last video, although we did cover how to do a train and test split, so again, the training set used to teach our machine learning model all of the patterns and representations in the data, and then the test set being the unseen data to, test it and make sure it really learned everything correctly, there's still a problem. And that if we take a look at this split 0 here, so if we had just run one split and let's say our model got really lucky and it just happened to do very well on the first 25% of our data. If we only run it one time, there's no real way of understanding that it got lucky, and we would think it's way better than it actually is, and that it actually understood a lot more of the patterns in the data and so on, way more than we would expect in the real world. Now, the way to combat this is with k-fold cross-validation. So we can perform multiple splits. As you can see in this image here, we have 4 different splits. And by doing that, we make sure that our model has actually been tested on every single data point in our data set. So as you can see, at the end of it, we've did the first quarter in the first split, the second quarter, third quarter, fourth quarter, and so on. And then we can just take the average of our model's performance across all 4 of those splits. Now, although that sounds great, I do want to point out here in this group column here. So for us in our Numerai tournament, the groupings are going to be the eras, again, the kind of time period that our data, every row is from. And as you can see though, the grouping by era does not line up well with the test set. This test set kind of cuts in the middle of this third era and then starts off in the middle, and they're mixed and matched into the different test sets. And that's not good. That's because we want to understand really granularly how well our model does during each era, because that's helpful for us and it's going to, be useful later on. And so because of that, there's actually a different way of grouping and doing cross-validation, and that's with group k-fold cross-validation. So what group k-fold cross-validation does is it just tweaks the regular k-fold, as you can see, and it just does the same idea of k-fold in doing multiple splits and making sure our model is tested on every data point, but it does take into consideration this group column, so the eras for us. And as you can see, what that looks like is that, let's use this first split as an example. This, every single test set, or it can be split here in 3 rather than just having 1. But as you can see, the components of the test set are going to line up 1-to-1 with our grouping column. So if we think to how we're going to use this, if we were to use group k-fold, eras 2, eras, I think this is 6, and eras, I think there's like 10 here. So 2, 6, and 10 would be our test eras for this first split. Now that's good because, again, we can know precisely if we did bad on this first split, we would know, okay, eras 2, 6, and 10 are bad for us, and we can go back and adjust our model based on those results. But there's still a problem with group k-fold for the Numerai tournament, and that is that because our eras are loosely time series, again, we don't know the exact date, it's not like a date column in Excel, but we do know that eras 1 is earlier than, era 100. We know that there is some time series element there. And because of that, it is a bit weird here that you would train on data in the future and then be asked to predict and test it on data in the past. So that's one element that we know group k-fold, just as it is here, is not accounting for, and that is the time series factor. So because of that, there's still an issue, and we're going to correct that. And that brings us to our last and the actual cross-validation technique we're going to be using for the Numerai tournament, which is the era-wise time series cross-validation. So as you can see here, we're still doing multiple splits, just like k-fold. We're going to take the average of that to determine our model's performance. And then we're still, if we look at the test sets, accounting for the group column. So it's still accounting for the eras. That's why it's the era-wise here in the name. But as you can also see, we are only ever predicting on data in the future. So we're always training on the past. So this first half is always going to be blue. And then predicting on the test set is always in the future. So it's taking account for that time series element that we just spoke about. Awesome. So now that we understand what we're doing with this, I'm going to scroll down and introduce this code snippet. So here, this is the code to specifically implement what we just saw in that image there. I'm not going to go line by line. I'm just going to give this to you. And that's because I didn't actually write it. This is something that I took from the Numerai forums. Now I actually have the exact post that I took it from here. This was posted by MDO. And I just wanted to bring this up first to say thank you to MDO for the code. But also I want to bring it up because, again, I really want to harp that if you aren't using the Numerai community, if you aren't using the forums, you aren't using the Rocket chat, then you are making your life way harder than it needs to be. Go in, don't just take, also if you have something useful to provide to the community, post something, don't be afraid to engage, because as you can see, there's a lot of common elements that every participant is going to touch on, and it's not going to necessarily expose or give away your technique just by providing some insight on a common topic. And that's why MDO did it, that by giving someone how you test your models, we all benefit from it because everyone can have a way to test their models more efficiently without having to, reinvent the wheel every time. So thank you to MDO. Just wanted to give a quick shout out and again, harp on everyone to get in and start posting more. Great. So now that we understand the code a bit more, let's move on to loss functions. So we've talked about how we are going to feed our data to our machine learning model and how we're going to use cross-validation to, chop it up and make sure we're getting a good understanding of how well our model actually is doing. But we haven't talked about what we're going to be grading our model on. That's what the loss function is, what we are grading them on. And in this case, this is going to be correlation. Okay, so we're using correlation for the Numerai tournament because compared to maybe mean squared error or R squared score, it does better out of sample. Now, I'm not going to show the proofs for that in this notebook. Again, that is included in the example scripts notebook from the Numerai team, and some really cool visuals around that. So I do suggest you do go check that out. Don't just take my word from it. But I want to quickly talk about the Numerai score function here. I also give the correlation score and the Spearman score. So that's just because I would suggest you stick with the Numerai score function as your go-to, your number one. But in some cases, these other two might be more convenient. So you can they're pretty much synonymous. You can swap them out. But if you do have the choice, go with the Numerai score function. This is what the Numerai team kind of gives out and is the closest to what you're actually going to be scored on in the live tournament. All right, so I'm actually going to call it there for today. I don't want the video lengths of these to go too long, and we were going on to like 25, 30 minutes. So I'm just going to cut it here and split it in two like I did with the last topic. If this content is helpful to you, please like and subscribe. I want to make sure that, everybody is engaging. So let me know in the comments if you have any feedback, or if you just want to reach out to me, you could do so in the Rocket Chat. So if you're not already in there or on the forums, get in there, be engaging, come out and, check in, tap in, whatever. Also, check out all my other socials. They're still in the GitHub, or any of these Jupiters are at my link tree above. So thanks for watching, and I'll see you in the next one. Peace.